Okay, thank you. So, once again, my name is Ogutumbi Shegun Samuel. Um, I'm from Nigeria. And I have BSc in physics and also postgraduate in maritime communication and navigation. Actually, I have the opportunity to be part of part of some organization that working with maritime that with care with quantum to reduce some noise in ships and some other areas, and also into tech. So for some period you'll be seeing me. So one of the instructor is on board and is one of the board members of Q1. I hope most of us know what Q1 is, and also is one of our board members of Q Nigeria, which is Quantum Nigeria, and also we have Quantum World, which we are in collaboration together. So for today, we're going to be talking about the introduction of quantum computing, and thank so much for Kiski that give us this opportunity to work with them and have the opportunity to teach and share this knowledge with other people. So I remember when cloud computing started, a lot of people were like, okay, what cloud computing is going to be, but many people today, many organizations are running into cloud computing to do what, to make use of, and also that's how it's going to be when as times goes on. I know some organization are already making use of quantum computing, like Samsung and some other like IBM, Google. We have Google AI, Google AI Quantum, and so on. So today we are just going to look into the basic, and before the instructor is going to take the floor, I would love us to have this at the back of our mind. You may see quantum computing as a very hard course or hard program language to work with, but we have many areas you can specialize on. You may not be into the dev area, but you can be into some other parts of quantum computing. Researcher, writer, we have those who are writing, those who are just doing research on it, and some other areas. We have the hardware, we have the software. So it's going to be a big platform for us to learn. To learn. I remember when I was doing one challenge with IBM. IBM, we tried to upload a data to the cloud with quantum computing. It's just in milliseconds. It's very fast, more than classical. All this computer, all this my headset, all what we are holding is being built from, we call it classical. Actually I study physics, so I know some of us are professors. I don't will be on board with us, but I just want us to have it at the back. We have class in, we call it mechanism. So we have quantum mechanism, we have classical mechanism. So on that quantum mechanism, that's where quantum computing come from. On the classical mechanism, that's where we have classical computing, which is what we are using basically based on 0 and 1. But today we are going to be learning why 1 and 1 are together, 0 and 0 are together, and 1 0 are together. So we are where you are going to be talking of superposition, entanglement, and so on. You will learn a lot and you will enjoy yourself in this. So let us look at the platform you are going to be using. The platform you are going to be using are so important. Actually, you can use a lot of platform. It's not just only this. It's just because of time, so that before you to set up, it's somewhat complicated to set up those environments. You have to go through the documentation, read how to set up, whereby we make use of Anaconda. From there, you are going to develop what you want to use from your Anaconda, and you set up, you have your Jupyter notebook. Also, you can make use of your VS Code. VS Code, and from VS Code, you install the library of Jupyter Notebook. When you install the library of Jupyter Notebook, you install which one, your QISKIT. Actually, if you are going to install, if you are going to be making use of your Jupyter, your VS Code, no matter how, you are still going to have your Anaconda on your system locally. So from there, you can run it locally, you can run it cloud, whereby you run it from the platform of the organization, Classic. Classic acts their own platform, whereby you can run the machine, everything. We have IBM. So today we are going to be showing you the IBM platform, whereby you need it. It's important. I posted it on platform that all of us to do what, to create an account with IBM. So from there, you can able to use the IBM platform. Also, you are going to be making use of Anaconda. Let me share my screen from here so that we can able to see what I'm talking about. Okay, just okay. Please, I hope you can see my screen. Please, I will be so happy. Let us respond. I hope you can see my screen. Can you see my screen, please? Okay, thank you so much. Thank you for that. Okay, so this is this is the platform you are going to be using to write your code, which is called Collab. It's being developed by Google, so you are going to be using Collab. It's very simple way. It's just for you to what, to create a new notebook. When you do that, it's going to load, and it's going to. So that's the platform. Actually, those who join the Python class, I explain how this notebook works. So give me some minute, let me just explain to you. So then we are going to be giving you the raw file. So the raw file, you can import this raw file here, and it's going to open. So let me go back so that I can explain that. Okay, so this is how it's going to open from there. You can upload from here. When you click upload, you go to your browser, you pick the Jupyter notebook that you've used. So actually, I have many Jupyter notes. Many notebook that I've worked with. So this is for the Python. This recently I worked with this classic program is a challenge, and also these are the notebook you'll be working with. So we have notebook 1, notebook 2, and notebook 3. So today we are going to be touching the notebook 1, whereby you are going to be being explained to how to navigate with that. And secondly, the IBM quantum website, which you'll be making use of. So this is the website. Just put it on your Google search and just type IBM Quantum. It's going to give you the page. So this is the page. From that page, actually, I think I've already logged in, so I don't want to log in again. Okay, sorry. It should be this one. Okay, so this is the platform. So you can see my name at the top here. Also, so why we need this? Because we have different version of quantum QISKIT. So from there, I think we start from 0.24, if I'm not mistaken, to 1 point something. So presently, all the 1 point something upward of version of QISKIT, they are being cloud. They are being put on cloud. So before we can run it locally on our system, but now you have to make use of the token. So you will need this token. This is my own token. So please keep your token safe. So you will need this token, and you copy this token. You have to, okay, let me just open the notebook. Actually, the instructor will still take you through. I just want us to know those are important. And so this is the program, and this is what you'll be running with. And from there is a part whereby you will put your token, and continue from there. So that's that. And before that, please, I will stop sharing. Before that, actually, we have some people on board. Some two people have to talk to us to let us know the reason why we need this content computing. You may be looking at it that, oh, what is going to be the usefulness of this? What is my own gain? Actually, those developed country like US, I remember when this US president, the vice president was talking with Trump in one of their debates. He mentioned whereby they drop up to like, is it 25 billion or millions of dollars for quantum computing research. I think Germany also did something of sort. Russia is doing that. So what is it going to make us to be left behind when they take this up? Where are we going to find ourselves? So it's going to be a great opportunity for us to have some of our board members in quantum world that are here. I think one of my chairman is here. So it's going to be talking to us about quantum computing, whereby we are going to be looking at some topics. His topic is he's a lecturer. He's going to introduce himself very well to us. So we have some little time for him to. I hope he's still with us. Yes. Mr. Ini, are you there? Please, if you are there, please unmute. Mr. Ini.
Yes, I'm here. Good evening, all.
Okay. Good evening, sir. Good evening. So he's going to be talking to us today about the potential of quantum computing and technologies. How prepared are we? Even India are prepared. Actually, they are, I respect them. I have the opportunity to be a mentor with these people with keyword. I really love them. Like, they are ready. And then I saw one post that India is the most highest CEO in the world, like in different organizations. So it's going to be a great part if we can be together and learn from different parts, from different people in this program for just 1 week. So we are going to be hearing from Mr. Ine, and from there, he's going to share screen, talk to us, and before that, actually, one of us supposed to be here. She messaged me. Is from one of our neighbor country in Africa. She's supposed to give us a talk, and from there, she has a little issue. Maybe if she join us, she will present and talk to us. I just want us to have more knowledge on it. So, Mr. Imin will be talking to us now. Thank you. You can have the floor, sir.
No. Hello, Sheikh. Hi, everyone. I think my time is 3:30. It's not yet time. So you can use this opportunity to engage the audience in the how to make good use of the lab, because I'm still setting up my
Okay.
system. Okay? Yeah.
Okay. I hope all of us can hear him clearly. He's still setting up the system. Actually, his time is not yet up for him. Is supposed to start by 3:30, but I just don't want to take much of our time. But from there, okay, let me just put us through. How many of us? Okay, let us just check something about Python again. Let me just throw a little light into the Python, because you must have this knowledge of Python, please. I know many of us do. For those of us who does not have the knowledge, I don't know. I should not just bother us with this too much. But okay, let's just open the floor, and let me open the floor, please. If you have anything to contribute, maybe questions, please, can you just, before we start, actually, the 30 minutes for the person that's supposed to talk to us is the one I'm using, because she has a delay, and she needs to be there. So please, let us be free. Let's talk, please. Let's introduce ourselves. Like, let's start from there. Please, let's introduce ourselves, please. So who's going first? I can see one brilliant name, yeah, Mr. Olutosin. Can you introduce yourself? Please, if I call your name or pronounce your name wrongly, please don't be angry. I'm so sorry. I'm not able to pronounce it properly. Just give me the permission. So please,
Well, it's okay. My name is Awila Olubumi Olutosin.
just
I'm CEO of Heptatech, and we are basically a hardware and software development company. And our focus is more or less like creating products that are smart for smart, sustainable living. So basically, we'll be doing something inside around AI, machine learning, and
wow.
some got interested in this cloud computing tool.
Wow. Yeah, well, you are in the right path. That's
Yeah.
great. That's for quantum computing. Because no matter how, you will need because things are changing. Um,
Yeah.
now you can, many of us can see what we they are building. I saw which space, whereby space is reversing back to the earth. Wow. So from there, a lot of things will be moving up and up. So from there we will get more. And okay, I don't know. I'm seeing it was this hmm, please, the floor is open, please. You can unmute yourself and talk, please. You can unmute yourself, please. Unmute yourself and talk. Unmute yourself.
Hello everyone,
Hello.
my name is Taslim. I'm an
Teslim.
IT
Okay, you are
engineer
welcome.
working in a medical diagnostic center.
Wow,
Now my main
that's
focus
good.
is on automating our processes using AI slash ML. And so
Okay,
using based on the large data that we actually store, it's
okay,
it's warranted that we actually start looking for more convenient ways. That's what led me to quantum computing.
okay. That's a great part. Thank you so much. That's good. Um, so I'm waiting for others to talk. Please don't let us be shy. We are free. Let us talk so that we can learn. We can know our background. Can know where everybody come from. Mr. Paul, Favor, please say something. I'm waiting for us. I'm waiting. I'm waiting for us.
Good afternoon.
Good afternoon, sir.
Yes, so I'm a student of Unilag studying statistics.
Wow, hey, great Akokite. Thank you for joining us. I'm with you.
Yes, thank you. So I have interest in machine learning basically. So I just saw this and
Okay,
I was like, what is this about? I just like did some Google search and I was like, okay, let me just see how it goes and all that. So I'm just here for the learning experience.
okay, thank you. Okay, he said something that captured my mind. Okay, we want to learn. He Google, he check about what quantum computer is. So let me just use this platform, explain a little bit. In a situation whereby you have a switch in your house, we have 0 and 1 on the switch box. The globe, the bulb that you have, you want to on it. When it's on is 1, when it's off is 0. That's just a communication of classical computing. Classical computing is deal with binary numbers. Why quantum computing will deal with qubit? Deal with qubit. So in this qubit, there is a situation whereby you can have a superposition of what, of different of a qubit, whereby it can be in 0 and 1 at the same time. Is it no, okay? Let's assume now you are sitting in your house and likewise you are in another state. That means you are appearing I think there are some movies that we've watched that we can see that you are appearing in another place. Just let us look at how it is. So that's how, that's I just trying to explain in a simple layman way. That's how quantum computing is more than that actually. I'm just still giving us the tip of it. It's more than that. Because now there are some organizations they want to reduce. I have the opportunity to participate with them. They want to reduce the noise of what, of planes. Actually, if a plane is passing by or you're out in nearby airport, you can hear the vibration and the noise. So their own work is what they are writing or developing different platform, different should I call it libraries or code that they will be using for developing that using quantum computing. So you have 0 and 1. Okay, let me just share my screen for, I think, how many minutes did I stay out? Okay, almost just 5 minutes. Okay, let me just share my screen before it comes up. Sorry, Mr. Neka, I will be sharing your work. So okay, let us look at this. So okay. Okay, looking at okay, let me just read through this QISKIT SDK. So the is the world most popular software stock for quantum computing. IBM built this QISKIT. Most companies, most others organizations are using it to run their own because it's much stronger with over 200 folks and over 800 contributors. Those who have contributed to it and over 300 circuit runs. So if you check my if I show you the last time I run sorry, the last one I did was October that I run. This is one of the what I run. So this October. So I'm among, let me just, I'm among those who, you can see the usage in 0 seconds, very fast. So looking at that, we have so QISKIT first emerged in 2017 as an open source software, which was developed for usage. But since then, it has evolved into a lot of usage now in the world, so that many people are using it, which optimize and carry a lot of quantum workload. So a lot of people have been using it, and it was imagined in 2017, but quantum computing did not start in 2017. Quantum computing, they have been doing a lot of research on quantum computing for some years, sorry, not days, for some years. So today, the QISKIT SDK is just one component in this software. It's just one component. You have a lot of it. So let me look for what we can still talk about. Okay, actually I should explain this, how to install, but it's going to take us through it. And okay, actually, okay, before I move forward, let's look at this. For about 95% of you, the answer is probably in a cloud-based tools, like Google Colab or Keybrain. This organization also is a quantum organization, Keybrain. I've worked with them. I've performed a lot of challenge with them. Actually, I should have put on their clothes today, but maybe next class, next meeting, I'll put some of their gifts which has been sent to me. And okay, let me just explain some things. If you have the opportunity, maybe you want to do masters in quantum computing or PhD. Actually, I can vouch for PhD very well. There are full funded scholarship. They will fund you, and you will be well trained. That I know. One of us that is in Q Nigeria have the opportunity. So from there, you can pick it up. Okay, let me put something at the back of them. All this blue link that we are saying is the link that you can click on that's going to take you to whatever areas that you need. Maybe you want to learn about the basic of quantum socket. Yeah, please, these notes will be dropped for us on the group, so you will participate with that. I just click on this link is as redirect me to this. Okay, keep going. So please, I will show us what. Actually, it's still going to our instructor is going to explain to us very well. Going through this, I'm looking for. Okay, you can see exercise 1, exercise that's exercise 2. So there is exercise 1. All this exercise, please, you need to work on them. So this is a platform still loading. I don't know, maybe because of network. Okay, you can watch the video at the top. Talking of socket, the way socket is, I don't know if any of us have the opportunity to do to study electronics. If you study electronics, that is when we did about we work on circuit layer, how to build circuit layer, because actually I did electronics with my physics, but I always tell people I study physics. I study physics with electronics. So, but it's physics I still study because I did just only 3 electronics course, but from there I did 3 practicals as well. So from there, I just have only 1 minute more. Mr. Imin, I hope you are ready for us. So from there, we work with we have to develop some circuit layer, design them from there. So that's how you'll be working with all these sockets as well. You design sockets, different sockets. We have different gates. If you did electronics in school, you will know what we call gates, AND gate, OR gate. But in quantum, we don't make use of AND gate, OR gate. We make use of S gate, H gate, Adamon gate, which is H gate. We have Z gate, and so on. We have a lot of gates that you will learn, and all these gates are so important. And also you will learn algorithm, quantum algorithm. We have a lot of algorithm. I think is it best state. You will have the opportunity to know what best state is. You have the opportunity to Glover algorithm. That Glover, those who are into database, data analysis make use of it very well, and so on. We have a lot of that. Mr. Imin, are you there? Mr. Imin, are you there? Um, maybe I don't know. Maybe we're going to start the main course today. Mr. Ime is not on board. Mr. Neka. Mr. Neka.
Hello. Yeah, I can hear you. Yeah, good
Okay,
evening.
I don't know what's. I don't know. Good
Evening,
evening. I don't know.
everyone.
Okay, he has joined back. That's one. Mr. Neka
Okay.
is one of our instructors who's going to be taking us today. But Mr. Ine is back. So Mr. Ine, please, you have the floor. We have been waiting for you. Hello, Mr. Ine. Can you hear me?
Hello?
Okay, good. Please, you have the floor. Please.
Hello, Shagun, can
What do you say? Hello, I can hear you. Hello. Hello. I think he's having network issue. Okay, Mr. Aneka.
Yes, I'm here with
Mr.
you.
Neka.
Yeah.
Okay, please.
Should we
I don't
do we
want.
have to wait for
Okay,
him,
just start.
or
Please, let's just start because I think many people are already in haste. So please, let's just, because I don't know his network or maybe he was trying to say something. We need to get to him. But you can take the floor,
or
please.
all right. Good evening, everyone. My name is Anyekan Afangide. Yes, I'm a computer engineering graduate. I'm a member of Q World, Q Nigeria, and of course, I'm doing AI, ML, and data science. So we are here. We are all here to help you understand what you need to understand to give you a proper introduction, right, in quantum computing. And so we are going to start. We are not going to waste any of your time. I'll start with the first notebook. There are a bunch of notebooks we have designed, we have curated, so that to give you the perfect introduction, it will guide you on how you need to go about understanding IBM Qiskit. We are using IBM Qiskit. There are a different bunch of modalities to use for quantum computing. IBM Qiskit is what we're going to be looking at right now. So someone was raising their hands. Is that okay?
He's saying that you are too loud also. Maybe just.
Oh, okay. All right, no problem. I think I'm too fast. I'll take it easy. All right, let me share my notebook. Let me share my screen. Okay. Can you see my screen? Can you see my screen?
Yes, we can see your screen. Yes.
Okay. Okay. So so this is the first notebook we are going to start with. I'm sure we'll give it to you at the end of this event, at the end of this particular live meeting. So this is welcome to QISKIT Fall Fest 2024. It will interest you to know that the QISKIT Fall Fest is held simultaneously across many universities worldwide. So Unilag is just one of them, and we are happy to introduce you people in our own little way. We are just holding our own events to introduce you, and we are happy to do that. So aside from that, you could see it's a relatively easy notebook. We have 30 minutes to get through everything. Sorry, I had to plug my system. We have 30 minutes to go through everything. So we are now introducing you to welcome to QISKIT Fall Fest. QISKIT Fall Fest is an annual event, right? It introduces people to the world of quantum computing with QISKIT, and it also helps you to learn the latest advances because QISKIT keeps updating every year. QISKIT is updated every year. So we need to always keep ourselves abreast with the latest version, the latest modalities, the latest functions and usability. So that's what this is all about. QISKIT is the framework for quantum computing by IBM. So anything you're doing with quantum computing through IBM, you use QISKIT. There are a whole lot of other modalities, but QISKIT is one of the pioneers, one of the easiest, and is based on Python. So I think we should go with it. So let's just go through to, you could take time to read all of this. QISKIT SDK is the world's most popular software stack for quantum computing with over 2,000 forks, 8,000 contributions on GitHub. You see, and there are over 3 trillion circuits run. When you open your IBM account, when you open your IBM quantum account, you would have access to real quantum devices and you'll be able to run your circuit from your system remotely on those devices. They give you actually a free limit per month, and then outside that, you have to subscribe. So that is what we're looking at. QISKIT is wonderful. It emerged 2017 and it has been updated since. It's an open source software development kit, so it's always having updates. I think we're on about version 1.03 or something, but we are going to go through it. So this is the first. This here shows you the maps, how to map your problem to quantum operators. This shows you some hardware target. If you click any of these are links. It will take you to a website where you're able to be, you will see some material on how to do this. So if you have this, When we give you this notebook, these are some hyperlinks. You click them and it will guide you on how to do this. Now let's go down and import the first stuff. So first you would need to install rather, you install QISKIT. I have already done this, but if you have not done it, you just press your Control Enter, and then that would install in your environment. Wait, let's see if that's done. We'll just hold on a little bit because it takes some time. You need to be connected to the internet just to install that. Yeah. So as you could see, requirements already satisfied. It means that I have already installed this. I already have this installed on my environment, on my system. And for those of you asking, I'm using my Anaconda Jupyter notebook. I'm running it locally on my system. You could also use Google Colab. Google Colab will be way easier for those of you who cannot have Anaconda on your system, right? So this my QISKIT is installed. Now we go to the next cell. Now this cell tells us to import an object from QISKIT. Now this object is called the quantum circuit. Now the quantum circuit is the most fundamental object in quantum computing, in QISKIT at least. So the quantum circuit gives you a framework. It gives you it's like how will I even put it? It's like a table where you put all the gates, all the operations on. So once you want to create a quantum code, a quantum algorithm, you start by importing the quantum circuit, right? So when you import the quantum circuit, as you see here, you create a new circuit, you instantiate a new circuit, call it QC. QC is equals to quantum circuit, and then you put in a parameter, you put 1. Now this 1 means that your quantum circuit has only one qubit, has only one qubit. Please, is everyone following me? Is everyone following me?
Yes.
Okay. So when you have that, QC is the quantum circuit, and then you've given it has 1 qubit. And next is that you add this X, this QC.X at the 0th qubit means that you apply an X gate. An X gate is like a NOT gate for those of you who know classical computing. So whatever the state was in the qubit, it gives the opposite of it, the X, the not of it, right? The inverse, rather. The inverse is the correct word. So when you're done with that, QC.draw is a function that helps you to draw this circuit. This MPL stands for matplotlib. It just helps you to draw it in a manner that is colorful. If you draw it normally, it will give you the same result, but it's going to be kind of it will not be as colorful as you could see. So now this is the output we have. You could see here this Q. This Q means a qubit. This is 1 qubit, and then this is the X gate, the NOT gate you could see on it, right? So that's okay. Now this is just telling you what you're meant to see, and you could see we got the correct output. Now there are many other dependencies that we need while running QISKIT. There are many other dependencies we need. You don't just need the quantum circuit. You still need to install other parts, other libraries that are related to QISKIT. Previously, all of them were still part of QISKIT, but now they kind of separated them. So we have QISKIT Air. QISKIT Air is used for simulation. You have QISKIT IBM Runtime. The IBM Runtime is used when you want to access a device, a real IBM quantum device. So if you want to access a device over the cloud, you use the IBM Runtime, right? Now we also have the matplotlib. I already have matplotlib installed on this environment. If not, this previous cell would have not run properly. Now this Pilotan Sneak library, this also helps when you're trying to display some images. It helps you to see the way you're seeing it. And the last one we install. This is the grader. The pip install the grader. The grader is a little function that helps you as you're running this notebook. There are a bunch of exercises you'll be seeing. So this grader helps you mark it if it's correct or wrong, right? So let's quickly install those. It might take a second, but I already have them. I'm just showing it so that you see what is going on. So that's going to install. Let's hold on a bit and then see what would show up with that. Yeah, so see, requirements already satisfied. I already have all these things in place. So yeah. Now the next stuff you could I've already imported QISKIT earlier on, but you could check the QISKIT version available. I just checked it so you know the version, and you see I have version 1.1. Version 1.1 is available here. That should be the latest at the moment, and we need to use it, or you still install a higher one. Look here, you need to have a version 1.2 or higher. You could still use this or a higher one. Do you understand? So that's that. And these are to check the other dependencies that we installed here to see if all of them are available. And you know there were a bunch of dependencies. Each of them are installing one after the other. Still loading, still loading, still loading. That's why this is still loading. You will load one thing at a time on a Jupyter notebook. So one needs to finish first before the other one. And it's still loading. We don't have a number yet. But let me just take you through because we don't have so much time. So now the most important thing here, I think, is you need to go to the IBM Quantum platform. Everyone needs to have an ID, an IBM Quantum ID. And it's that ID that you use here. It's like your token. And that token is used whenever you're trying to run a remote quantum task, a remote load. If not, you will not be able to work on real quantum devices. So you quickly go to IBM Quantum, you navigate there, look at the link here, you just browse IBM Quantum online on your Google or your Chrome or whatever you're using for browsing. And when you get there, you register. You have to accept a whole bunch of things, you register, and with that, you have access to your IBM Quantum platform. And that will help you to be able to get your token, and that token will be needed on subsequent when we have the QISKIT summer school. There are a whole lot of events that happens, and when you're trying to run stuff, you need that token ID. So does everyone here have their token IDs in place? Hello?
Hello, do we have
Hello?
our token? Because I've posted it on the platform that we should create an account with IBM Quantum. So that token is important. I don't know. Do we have?
Okay, you've told them to get the token
Yes.
before. Okay, that means most of them should have had it by now. Most of them should have had it by now. But anyways, if you don't have your token, you need to work on it, because without that, we won't be able to proceed. You won't be able to proceed because we are going to run on hardware and subsequent examples. So you enter your token here. Let me get my token so that I could work with you people. That's my token there. So that's my token. You need to get your token and link it to, right? So after that, we do some imports. Now these imports are going to help us run the example we are doing. We are going to try out some sparse poly operations. So we're going to try some poly operations for those of you who are conversant with some things about how will I put it, vector matrices and some other stuff. These are just some vector operations that we are going to run, some space poly operations. So this is, you're testing the grader, you test the grader, and then
Sorry, someone is raising up his hand. I don't know. Mr. You want to say something, please?
Yes. Okay. Can you hear me?
yes, I can hear you. Go on.
Okay. I think you can see the participant
Yeah, please come on. We can't hear you.
Okay, what I'm saying is I would love the participant to, do this exercise alongside you, where there's on
Please just move away your target now. Speaking up.
Okay, please, if you're not presenting, turn off your mic so that we could hear one person at a time. You understand? So one person at a time would speak.
Sorry, Mr. Hine, please. I think maybe you're on speaker, loudspeaker. Please use a neutral um voice. Just just use one phone to, or one system to communicate to us, please. Or can you drop it in the chat? I don't know if you can hear me. Please drop it in the chat, sir. Because it's sounding, it's bouncing back and there's an echo. It's noisy. Please, you
Okay,
can
what he
continue.
said was that he wanted more people. Please, if you're a participant, you could just join
Okay,
and try and run.
no problem.
Yeah.
And you can continue. Let me clear the echo.
Sorry, you are
Continue.
clear
Let me
now. You
clear.
are clear now. You are
Okay,
clear now. You can
my
go on, sir.
question is, my question is, let the participants also join in doing this exercise if they are with their system, especially to copy the token and get the lab running. That's the point I'm making. Okay.
Thank you, sir.
If they are not with their
Okay,
system,
please.
no problem. They can always post questions in the Discord or the platform where everyone is.
Okay,
Okay.
sir. Please. Okay,
But
sir.
if that's
Please, if
not
you are with your
possible,
laptop,
Nathan can continue. Let me arrange everything in my session
okay,
because I'm
sir.
having a
Please,
network
if you are
issue
with your
here.
laptop,
Yep.
please, if you are with your laptop, please just connect with us and follow what is Mr. Neka is doing so that you can get it well. And actually, we are here for you to answer your questions. Anything you need, you can post it on the platform. But the best thing is practice along with him, so you can able to get what he's doing. So you can go to IBM Quantum and pick and sign up and then pick your token. You can continue, sir.
All right. Thank you. Thank you very much. So, okay. So this is just testing. This particular cell is testing the grader if it works. So the grader will always grade. The grader is a function. It tests a variable. So you don't change anything from these notebooks. If you're given some variables names, don't change them. Just put your code into the part that asks you to put your code. So yeah, it just says answer 42, and then in the grader you're not going to see, it's going to check if this answer is 42, and then you see here it gave me my answer is correct. It shows that you have successfully figured out how to use the grader for these notebooks, and you see everything is working well. So let's proceed and check for okay, this is the next example given, how to generate a 2-qubit Bell state. Now, the Bell state is one of the most fundamental quantum, how will I say, quantum processing blocks that we are going to use, code blocks. The Bell state is just a combination of a Hadamard and a bunch of C0 gates, right? So if you have 2-qubit Bell state, it means you are only going to be using one Hadamard and one C0 gate, and it could be used in a whole bunch of things. I wrote some there. It could be used for teleportation, super dense coding, it can be used for cryptography, and so on. So let's see how we create the Bell state. So the Bell state, since the 2-qubit Bell state, we initialize our quantum circuit. QC is equals to quantum circuit 2, is 2-qubit quantum circuit, and then we now give a Hadamard on the qubit 0. The qubit 0 is the first qubit. When you're dealing with QISKIT starts counting the qubits from 0. So 0 is the first one, and 1 is the second one, right? You need to understand that because sometimes it could be a little bit confusing and could give you errors later on. So look at it. If we run this now, this is it. So the qubit 0, you have a Hadamard gate. A Hadamard gate simply puts you in a superposition. Remember, we spoke about an X gate before. An X gate is simply a NOT operator, an inverse. So this one is a Hadamard gate, and it gives you in a superposition. A superposition simply means that it puts you in a multitude of states. You're not just in state 0, you're in a multiple of states within 0. And then this Bell state, if you think of it, is actually a very funny logical statement, because you put in a multiple array of states, what we call a Schrodinger equation. You have how do you put it? I'll remember the term and then tell you later on. But when you put in a multiple position of states, this C naught gate is called CX gate or C naught. It checks this first qubit. If it is 0, it checks the first qubit, the target, the control qubit. This Q0 is called the control qubit, because you're looking at here, this qubit is controlling this second one. This qubit is controlling this second one. So if this first one, the Q0, is 1, it immediately flips the second one, right? And if it is 0, it leaves the second one the same way it was, right? So that's a so it is based on this superposition, and then it is now having this control. So it's always a probability distribution. Exactly, that's what I was looking for, a probability distribution. So that's what this Bell state is used for, and it has a whole bunch of use cases. This is just a sample of a code block. Yep. So when you run this, we want to check if our circuit does what we want to do. So let's go on. So now this exercise 2, it says that in this exercise, you need to complete the list of operators. We have provided you with 3 for you already. We have provided 3 for you already. The ZZ, this means 2 Z gates. A Z gate is simply a gate that it flips in the Z axis. It's just like an X gate, but in a block sphere, we have the Z axis too. The Z axis is your normal up and down, so it flips along the Z axis. The X axis is your normal horizontal axis. I would share the image of a block sphere. I have it somewhere here. Let me check if I could share that quickly. Right. So let me share that. Okay, this is the image of a block sphere. This is a block sphere. Now, this block sphere, now what it does is that it shows us the combined probability of states, a position of states in a qubit. It represents a qubit. Now, this up means 0, and then this down is 1. So the state is naturally at 0. Now, if we come over to the right, this is just a kind of implementation on GitHub. I'll share the link to you later in the chat so you could check it out. Right, so the link is in the chat. So if you check it out, you see that when you click on the X gate flips it from the 0 to the 1, as we spoke about. The X gate flips it from 0 to the 1, and then you click on the X back, it flips it back to 0, right? So that's your basic X gate. The Z gate, actually, it flips it along the Z axis. The Z axis is this axis you see. And if it's on state 0, it doesn't actually flip because it still remains where it is. It can't move from state 0 in the Z axis. But at some other state, if you have a Hadamard state, it gives you a superposition. Right now, look at what happened if we click on the Z from this position. You see it flips round from the plus state to the minus state. So the Z gate is simply a kind of X gate, but in another axis. In another axis, you need to understand the term axis. When you deal with Cartesian plane, you know that we have 2 axes, Y and X. So the Z axis is just a third axis to give it a 3D viewing, a 3D viewing angle. So just check and play along with these two. It will help you understand and visualize a block sphere. So let me go back to what I was presenting before. Yeah, right. So this is now, this exercise 2 is trying to telling us to actually perform some gates on a quantum circuit. So on some qubits. So now look at what we're going to do. This X gate stands for the NOT gate, yes. This Z gate stands for the NOT gate on the Z axis, and this I gate is an identity gate. It's just like identities when you're dealing with multiplication. When one times in any number times its identity is still that number, right? So we are going to work on a bunch of combination of this, right? So what we're looking at is xi, that is the NOT gate and the I gate and the identity. I'm looking for the identity and the NOT gate. We are also looking at the Z gate and the identity and Z gate. So those are just the combinations. We are just trying to run those in exercise 2. That's what we are doing, right? So they gave us these three, the Z gate and the Z gate. That's running the Z gate 2 times, running the Z gate and the I gate in this run, running the I gate and the X gate, and then they asked us to get the other 3. Just the mere looking at it, you know that the other 3 are going to be the I gate and the Z gate, the Z and the I, the X and the I, the X and the X. It's just a combination of all of them. It's just a combination of all of them. So the deliverables, the observables rather, we are going to have it in a list. This is actually a list. So you pick all of these things you define here and put them in a list. And if you run them, yes, it's run. Now you put it and check if this is the correct answer, and voila, you get your answer. Let's check this out. So the grader is running, and here you get your answer. So that's how quantum computing is very sweet, very interesting, very intuitive. Do you understand? So I would advise you to just go through this material, look at what you need to do, and then get yourself conversant with the information. Now we have to optimize the circuit. To optimize the circuit, you don't just run a circuit, because why don't we just run a circuit? That's very interesting. Whenever you run a circuit on an IBM device, those devices don't work. Like now we had these observables, we had the I gate, the Z gate, the X gate. Those devices like the IBM Sherbrooke, IBM there are very many, IBM Tokyo, IBM. Those are the names of the computers. If you check the IBM quantum computers, so they don't actually work on these native gates. They have their own set of gates. They have their own gates. So whenever you run a code like these observables, it changes it. The new IBM version, QISKIT version rather, changes all these gates you put, and then changes into the native gates of the back end you're running it on. So it needs to be changed. So that's what you need to do. You optimize it so that it will be changed. Let's check for the necessary. And here we are using the estimator. The estimator is used to estimate the state it will come out at. We have 2 major ways we run this thing. We have the estimator and the sampler. The sampler actually gives you a sample of results, a probability, amplitude, a bunch of samples, whereas the estimator gives you an estimated state. So let's try and run this. Yep. And then we put in the data we had and try and post-process the results, so you could get a graph that shows the result. Yeah, so this is the graph now. This is the graph. You plot it out. So these are the observables of the IZ gate, the IX, the ZI, the XI, the ZZ, and the XX gate. It shows you the state, if it was actually still remaining in 0 or 1. So the ZZ gate remains at 1, the XX gate remains at 1, but these other ones, you see them, they are a little bit lower. They are almost at 0. And you could try it out using that tool I did. Just if you could get I, Z, and then you see the result for yourself, right? So let's get this, plot it into a bar chart. And then this will show, this is actually similar to what is there. This was a line graph, this is a bar chart. And so that comes to the end of this. This is the first notebook. Then, sorry, this one was run locally. This was actually run using the AER simulator. It used the AER simulator. So it ran locally here, an estimator on your system. You understand? So this was not taken to any backend. You did not take it to IBM Cloud. You could just do this wherever you are on your device, on your Colab, or your system. Do you understand? So this is just a tip of what quantum computing and QISKIT has to offer for you. And it's a very welcome, very exciting world out there. So I'll just advise you go through this, you look at what you need to learn. There's a whole lot of materials. You could reach out to any one of your mentors throughout the course, and then you get yourself abreast and get yourself tuned to follow up the world of quantum computing. There's a whole lot for everyone, and I hope you could find your place. I pray and wish every one of you success, and thank you. Thank you very much.
Thank you, Mr. Neka. Thank you so much. Thank you. Please, is there any question? Is anybody that have any question? Any question? Any question? You have a lot of questions to ask. You may just be looking at, say, okay, this thing is just a diagram. It's more than diagram, because they will give you a mathematical equation and ask you to convert it to quantum code. So please, any question, any question, any question. You have a lot of researchers that they've worked on this. Okay, if let me just share something. Let me share. Let me share one of my work so that you can see that it's. Oh, sorry, I'm running. I have a low battery. I may not able to share. I may not able to share. I've loved to share one of my work. So please, from there, let's move to Mr. Ine. Let Mr. Ine take the floor. Please, if there is no question, Mr. Ine, please, we want you to put them through and explain why we need quantum computing, what is going to benefit them. So please, you can take the floor, sir. Thank you. Mr. Ine. Mr. Ine, unmute yourself. Someone is asking if you can use the platform. Can I use IBM learning platform to learn? Yes, you can. That's the main source. You can. Mr. Ine, please, can you take the floor? I think.
Yes.
Okay, good.
I'm trying to share. I'm trying to share my screen. Please bear with me for some seconds. Let me share my screen.
Mr. Neka, can you stop sharing?
Please, can you see my screen? Hello? Please, can you see my screen?
No.
Not yet. Okay.
No. Yes.
It will soon come up. Please bear with me. It's not my fault. It's a network issue.
I'm sorry, please. Is having network issue. That's why. Mr. Ine, can you share me the file so I can help you? Huh? Sorry, I'm on low battery. Okay, someone is asking a question here. He said, how do I use the platform to learn? Okay, if you are using the platform to learn, there is some areas whereby you will see some code, and they will explain what the code can do. They will post the explanation. Okay, this is what you can do with this, and from there you can just follow those steps. And actually, every year, Kiskit do a lot of programs that you can join, so you can learn from there too. And if you still want to, I will share the platform, I will share keyword platform whereby you can join the Q Nigerian platform, whereby you can join us and learn more from there. And also, I can share you some files you can work. And as times goes on, if you are still on the platform, there are some documents, there are some link I'll be dropping on that platform to just keep us growing in it. So, but the basic thing is documentation. Go through documentation. That platform is documentation. That platform, Quantum platform, is the documentation. So you will see documentation. Click on documentation link, and it's going to give you introduction to introduction to um sockets, or introduction to Qiskit. Question, please. Still waiting for Mr. and Mr. Amy. So I don't know, maybe we are having a serious network issue. Any question? Any question, please? Mr. Aneka, can you hear Mr. Aneka?
Okay, yes, I'm still here.
Okay, please. I don't know what happened. Is in me. I don't know. Maybe join us.
He just joined
Please, sorry
now.
for the
He
delay.
just joined.
Is his network? Yeah. So is his network? We are very sorry about that. Please, are you with us, Mr. Me? Can you present now? I don't know if you can just send your file to an card to help you present it. I don't know if
Yes.
you can hear me.
Can you hear me?
Present for
Hello,
you.
please, can you hear me?
Yes, we can hear
Can you
you.
hear? All
We
right,
can hear
cool.
you.
Okay, so I apologize for the network issue. I'm going to share my file now, please. All right, please, can you see my screen? Please, can you see my screen?
No, still loading.
Still loading, okay. Just a few seconds.
Yes, it has not come up yet.
Wow.
It has not come up yet.
It has not come out yet. Okay, let me also use the opportunity to send it to an account to help me present it. Wow. Mhm. Please, can you see it? Wow. Okay. Shegun, I think I'm not video. Okay. So
what is it?
I want to share it with you so that you can help me put it on, because like there's I'm seeing an error here from my side. Let me send it to you. Can you hear me now? Can you hear me now? Okay. Please let me send it fast so that
you can.
Let me send.
No, send it to Aneka. I'm going to go off. My system is low.
Okay.
My system is low. Sorry.
Okay.
Send it to Aneka.
All right. Let me send it to. Okay. Thank you. So while doing that, Shane, you can get the team engaged. Let me send the file to Aneka, please.
As you're sending it, you can just be explaining part of it. So, okay, let me just pick. There is a question here, which says first installing. Okay, I think someone is answering the question there. Okay, thank you. You can go on, sir.
Okay. Few seconds. Let me just make sure that the file is leaving my desk so that I can concentrate. Just few seconds, please.
Aneka, have you received it?
Okay, I'm still checking. I'm yet to.
Now, Aneka, I'm sending it to your.
Okay.
I want to send it to your WhatsApp. Is it okay?
Okay. Yes. Just I'm active now.
Okay. Just few seconds. Oh God.
We are so sorry.
Okay, Aneka, I'll send it to your mail.
Okay, please a second while I get through with that.
From that. Sorry, please. I'm sending this to the group. Please pick up. So you can pick down on up, please. You can go through.
Aneka, have you seen it?
Yes, please. I need access. Please just
Okay. Working on it.
Sorry, you need access to
the slides. The slides
share.
have been yeah.
Okay, encrypted. Okay. So please, you can go through that. So it talks about the AND gate, OR gate, and some other gates. Yeah, we all need that, and so
okay,
all the
Aneka, I've
gates
given you
was
access.
Okay, thank you. Great.
All right. Thank you very much.
For those who are asking where you can learn that link I dropped for you, you can learn a lot. You will see all the library you need to import. Just copy and paste. So from there, you can run your first code by saying socket is equal to quantum socket 1, and also you start calling each of the socket for the gate. We have the H gate, we have the S gate. Sorry, I would love to share my screen, but I'm on a low battery. My system is low. It may not carry it. So, Mr. Aneka, are we good to go? Okay.
Okay, yeah, can you see my screen? Okay, let's get through to it.
All right.
Please,
Okay.
yeah.
Thank you very much. Please, I apologize for the mix-up. It's not really my fault. Okay, my name is Ini Ekpenyonkud, as you can see here. Though I'm a preventive maintenance engineer, I'm not a lecturer, but I lecture part-time. What I lecture is quantum computing. I'm a quantum ambassador, I'm a mentor. You can next screen. Okay, this agenda for this presentation, we'll start with the introduction, quantum information science, the pillars, the proposed preparation steps, then what next we need to do to be in the field of quantum computing. Next. All right. Okay, now, reminder, please. In 1947, where we had the first quantum revolution, it was in the boom like we are experiencing now, where so many companies, so many research institutions, government, countries went into research, pumping money to see how they can harness the properties of quantum mechanics for the usefulness of mankind. And at the end of it all, we came out with transistors, lasers, GPS, photovoltaic cells, atom clocks, medical imaging, digital photography, video, LED, and the rest. That was far back 1947. But in 19, no, if I want you to move, I will tell you. So then from there came a second revolution, which is quantum revolution, where we had making use of the properties of quantum mechanics, superposition and entanglement, as was discussed by some minutes ago by Shegun and Anekan. I would suggest we'll give them some beginners-friendly video, let them really understand about what it means to have a quantum state or a particle to be in the state of superposition or entanglement. All right. So next slide, please. Now, quantum computing and technologies is a very interesting domain in the sense that if whatever your background is, you can learn quantum computing. It's about the mindset, it's about the passion and commitment. Here you have, if you are a physicist, you're going to, in the field of quantum mechanics, you're going to meet electromagnetism, quantum physics, quantum matter, thermodynamics, fluid mechanics, and photonics. Can you mute your mic? All right, okay. Thank you.
Let me try.
Mute your mic. All right. Then you have engineers. Then what are they going to be doing? They're in this field of quantum, in the field of quantum computing and technologies, you're going to have material design, electronics engineering, and cryonics. Then in mathematician, you're going to have, in this field, you're going to have linear algebra, group theory, analysis, complex theory. Then computer scientists, you're going to have learn information tech theory, algorithm design for programming, classical computing, and telecommunication. Then people in human sciences, we're going to learn the philosophy, the epistemology, the sociology, technological ethics, economics of development, research and development policy, startup ecosystem. So what we are saying here, so long as you come into this ecosystem, these are the things you are going to learn. So if you know that you are not so strong in a particular session. You can migrate to another session. There's something for everyone in this domain. So as we are progressing, you will see how people in the humanities can come into the field of quantum computing and still be useful to the development and research in the field of quantum computing and technology. Next slide. Now, like I said, the pillars of quantum information science, which is quantum information science, can also be called quantum computing and technology, because under it you have quantum computing, quantum networking and communications, quantum sensing and meteorology, and quantum simulations. Next slide. These pillars, these four pillars for quantum information science or quantum computing and technologies has different applications. One of the applications, you have application in energy and material, battery design, renewable optimization, material design, fertilizers production improvement. You have in the healthcare. I know that there's a medical person here. While I was listening to the introduction, it's a medical person here, so you can leverage on this to see how you can optimize the field of medicine. You have in healthcare, molecular simulation, drug discovery. You also have in transport and logistics, travel optimization, fleet management, electric vehicles recharging, defense and intelligence. Where I also heard we also have a machine learning scientist or engineer in our midst. You can leverage on that. You have the machine learning, optimization, and cryptology. Next slide. Yeah. On this slide, we are taking time to elaborate on the applications, potential application of quantum computing and technologies. The first one I mentioned there was quantum sensing and meteorology. Here you have the precision of, it helps in the precision of weather prediction. Right now we have weather prediction. As we all know, sometimes information from meteorological department will come, 90% of it will be true, 10% will not be true. Is because the precision is not really there, because we are currently making use of our classical computers, any classical computers, or everything related to the system to give us these results is in a classical mode. So quantum computing and technology has come to help us have a precise information whereby when a forecast is made, if the forecast is that it's going to rain tomorrow, by tomorrow we should see rain coming. So you can see it can detect subtle variation in temperatures, pressure, magnetic field. This is done by integrating precision sensors into a weather monitoring system. Can also improve climate monitoring, enhance ability to track long-term changes in atmosphere properties such as CO2, sea level rise, and ice melt. It helps in enhancing remote sensing from satellite. This could improve the precision of Earth observation, thereby allowing meteorologists to gather global atmospheric conditions, ocean temperatures, and the rest. We also have geophysical mapping gravimeters, which measures gravitational fields with great precision and can be used to track seasonal changes in groundwater level, potential for natural hazard like flood and landslides. Please, next slide. Then under quantum network and communication, you have here that there's a protocol called quantum key distribution, which uses the properties of quantum entanglement to intercept it or is dropped on communication channel, and this will revolutionize cybersecurity. I put here on the slide 3 recent breakthrough in quantum communication, where the Chinese researchers have been able to use one of the quantum computers called D-Wave. The headquarters is in Canada to decrypt the present encryption code that is used in bank and other financial institutions, even government. But there's a politics in this. China, like I said, quantum information science has 4 pillars. China is focusing on quantum network and communication, whereas US and Europe are focusing on quantum computing. The Chinese have made breakthrough in this area of quantum computing and information science. So I've put a link here, which I'm going to share on the chat. After this class, you guys can go through it and read through it yourself, what those guys have been able to do. They have been able to they have been able to hack some secret codes of military defense of some people. Then also there's also this quantum 5 phones made in South just last month. There's a chip currently designed with that chip has quantum entanglement principle applied in the design of the chip, and they have started using it in their phones. But because this field is an emerging field, it's evolving, so the people don't want to share what they know. So that phone is presently can only be used in South Korea. They have not sent it out to any other country. So I'll put the link here. Let me copy the link and put here so that we can go through this link after this class to see, read on our own and see the breakthrough that they have had in this. Okay, let me put the link. Okay, I just put one of the links here. Let me put the next one. All right, I've shared all the latest breakthrough in quantum information and sciences. Okay, thank you. So, Nega, please next slide. All right, quantum simulation, like the man in the healthcare can leverage on this. You have drug discovery and molecular modeling. And the people in healthcare will agree with me that it's always difficult to understand to model protein and other stuff, other complex molecule. So because for you to be able to do that and get the precision, you need to understand the atomic level we need to understand the atomic level of the molecule very well. But our present computer cannot help us to do that. It has a limit to which it can, get us the information that we want for better modeling of our drugs. So with the coming of quantum computers, we'll be able to revolutionalize drug discovery by enabling scientists to simulate protein enzymes and complex molecules. We also have for material science and chemistry, by modeling atomic structure and properties, it can predict new materials with specific properties such as battery, high temperatures, superconductors, and more efficient catalysts for industrial processes. Please, if you have questions, you can pause me and I won't hesitate to answer it. Next slide. We also have in cryptography and cybersecurity. I've already said I'll share the link what China, as Chinese scientists have been able to do recently. Is not quite long. Then you also have an optimization problem where you have logistics, supply chain, workforce scheduling. Then in this my slide, I specifically put the company that is using this D-Wave in Canada to there's a quantum computing to schedule the workforce of their staff because of the large population of the staff I've indicated here in this presentation. I hope we can see it. Also for drugs discovery, the same thing. We have drugs discovery and healthcare, which I've already mentioned of it. Then we have for artificial intelligence and machine learning. You know, quantum computer has come so that whatever training of that modeling we are going to do, we need to increase the precision so that our prediction can be accurate. That is why when you come to the field of quantum computing, when you come to the field of quantum computing, you're going to have quantum machine learning. It helps to speed up a task, and especially in the areas like pattern recognition, data clustering, and complex decision-making process. You also have it in climate modeling and energy system. This one that we always have in national grid collapse. I wish the people concerned can know what is happening in the world and see how they can leverage on this, new technology that is before us. All right, next slide. All right, so having shared these potential applications of quantum computing, at this point, I think we as a people will need to now see how do we benefit from this. I think one of the things that I propose that we should train our workforce development. And under workforce development, I said we can be attending online and on-site trainings, participate in projects and hackathons. People can apply for master's degree and PhD in quantum information science and technology. Why the most of the online courses you're going to see right now in the field of quantum computing and technology is free. You know why? It's because the demand is more than the supply, so it is free. So before they start billing people, we need to key into this early stage of the technology and see how we can gain knowledge and be ready for tomorrow's for tomorrow. Then when you learn skill, you need to participate in projects. If you don't participate in projects, the skill you learn will not remain in you. If you could recall, while we were in school, when we prepare for exams, we read and write, then pass. But those homework, assignment given to us by our lecturers, once we do it, I don't mean the one we go into our library and copy, I mean the ones we painstakingly do research and do it. Even when we graduated, we still learn it. We still remember it. That is why important. Whatever skill you learn, you need to participate in projects. Even if you do not win anything in any project or hackathon, but you will learn new things, learn new things and master the skill. So that is how one of the ways we can develop ourselves. Then the second one there is to design a quantum science roadmap for the country. I think the government at this point needs to now design a roadmap for us to see what do we need to do now so that we'll be able to march alongside other countries of the world. I can tell you from my years of experience in this field, when it comes to Africa, the only country that I know that are making waves in quantum computing is South Africa. Just recently, if you check IBM, and once you can check the IBM data centers, just recently that we now have in Nigeria, and it's in Lagos. So, North Africans are trying, but West, East, and Central, we are not going anywhere. But if you go to Europe and Western world, they have gone far. So they need to design a roadmap. Last year, I was opportune to be in a team that helped in designing roadmap for Saudi Arabia under Aramco. So the country needs to now sit down and design a roadmap. All these courses that we did in school, and we came out from the university, or with some of us that are still in the university, we think they were not useful. Actually, they were useful because there was nobody there to tell us the application of this thing. That's why once you come into the field of quantum computing, you now appreciate why you did probability. You now appreciate why you did linear algebra, matrices, and other mathematical courses. So I said that the government, academic research institutions, companies, and government at state and federal level should work together to redesign school curriculum to accommodate these new technology courses. They are already there, but something is lacking. There's no interconnect between those courses. Take, for instance, The people in physics department are still learning this programming language, this ancient programming language called COBOL. Is it Fortran? Whereas the technology has evolved. If they can change those programming language and bring in Python or bring in Java, all those new programming language, so that you'll be as the technology is progressing, you're also progressing in the same wavelength with the technology. So that would be good. Then we also need to have international collaboration, because we here in Nigeria do not have all what it takes to say, let us do it on our own. We need to collaborate with other company outside Nigeria and institution outside Nigeria. They are always there to support. I tell you, they are always there to support this. It's for us to show commitment and passion. They are always there to support. Please, next slide, Anekan. Then what next? Like Shegun has said, you need to enroll in IBM Quantum Learning. IBM Quantum Learning is not just the platform, but because this event is being sponsored by them, but we need to emphasize on them. There are other so many platforms. You have Penny, but as far as I know, the field of quantum computing, IBM, when you want to learn the basics, IBM is the best, is the best, one of the best platforms to go. Then we have an organization here in Nigeria where we discuss, have trainings on quantum computing from the beginners friendly level to high advanced. So this next month, we're going to have a training. So I encourage you guys to check on the website and join Q Nigeria. Q Nigeria is a branch of Q World, an organization that organizes training, digital training, and create awareness for quantum computing and technologies. Then you need to enroll, and also can also enroll in quantum computing courses in EDS platform. But this other one, they will charge you small money at least. Yeah, 14. They see that when once you apply for financial aid, they will give you 10%. They'll give you 90% scholarship. What you will pay is 10%, which is depending on the cost, they will give you 90% scholarship. So that's all for me. I wait for any question from the audience. Thank you.
Thank you so much. Thank you so much. Thank you so much. Thank you so much. I don't know if anybody have a question. He's one of our board members of Q Nigeria. I just finished talking to us, and actually, our president for Q Nigeria will still come on board. Maybe that should be the next um, notebook class for us. Is still going to come. He's going to talk to us and he's going to put us through. And I'm still expecting one of. I think she's from is it Zimbabwe. She was supposed to present to us today, but she told me her friend has a serious issue she needs to attend to. So maybe I will talk to her because she was telling me by 5:30 she will join us, but I don't think we can wait till that. Thank you so much, everybody. If you have any question, Mr. Ine is still with us. So please, sorry. Actually, I thought my boss is a lecturer because he teach very well. He explains things to us very well. So please, he's a mentor. So also, Mr. Aneka, thank you so much for your time. Those are the people that are holding the Q Nigeria. So if you see them, you should know that these are the people that you can work with. They are ready to train you. They are ready to groom you and ready to help you. So actually, I know some people are with us who are from other country. So I really appreciate your time being with us. Actually, I know you may not have the opportunity to join Q World, Q Nigeria, but you can join Q World. Actually, Indians, I don't know if India is in the part of the Q. Mr. Ini, is Indian part of the?
Yeah.
Yes, actually,
It's global. Yeah.
okay, so
it's global. Yeah.
it's global. So please, you can join Q India. I don't know if it's Q India they call it, but I think you call it by Q for each country.
It's Q India.
So
Yeah.
please, you
Q
can
India.
join
Yeah.
Q India. Please, you can join Q India. Actually, I've worked with some of your
members very well for the Intel keyword Intel, which was just finished. And I don't know if my student is here also because I think I told some of them to join the platform. So thank you so much. Thank you. Thank you. Please, is there any question before we move forward? Because actually I will be dropping the notes on the platform. Please, if you're not on the platform, maybe you join through Telegram or Instagram or any social media. Please let me know before we close for the day so that I can just share the link to you. You can join the platform on WhatsApp. I'm sorry we're unable to open Discord. It's only MQ Nigeria that is on Discord that you can join. But this program is not on Discord presently. Maybe in future we can join that. So please, I'll be so happy if so that I will drop. Please don't let us look at there is nothing given to us. So why will I waste my time? So please, I will drop the notebook and from there you can just do what work with it, do the do just try your best, read through the documentation and just assess it. Please, there is a tangible thing. You may look at the certificate as what is this, but no matter where that certificate you present that certificate, they will acknowledge you as a computer, sorry, as a quantum developer, quantum computing developer. So please try your best, and what and work with that. So thank you so much. I don't know, Mr. Neka, do you have anything? And is there anybody that wants to ask any question? Anybody that wants to ask any question? So this is where we're going to drop our hand code today. So anybody, any question? Actually, I can't hold us down till 5:30 for my our other colleague. She's the president of Q Zimbabwe. She's the president of Q Zimbabwe. We're so happy if she's here. She will have explained a lot to us. So she's a lady that is in the that is in tech. She's a lady. She has represented Zimbabwe in many occasions. And I don't know, there is one of our brothers that is in medical line. Is in the quantum. She is learning quantum computing. Actually, he has been with us for a long period of time. I don't know if he's here. I've forgotten the name. Please, if you are hearing me, please can you simplify? Can you just unmute yourself and please acknowledge that he's a medical practitioner, he's a student. Don't let me say practitioner, he's a student, still learning. I think he's in his final year if he's here. And if he's not, no problem. Maybe he was unable to join us. So thank you very much. Thank you. Mr. Neka, do you have anything to say?
Okay. Thank you very much, Mr. Samuel. Thank you, Mr. Eddie. Thank you, everyone who is here. I just have to tell you that this is a very, very wonderful and exciting field. There is hardware, prospects, software, everything you dream of. Just have the dream, and we'll grow it step by step. Many of us are still training ourselves. Me personally, there's a whole lot of materials you could see online. So just have the dream, have the focus, and then we'll build together a team that will help you walk to success. So thank you very much. Thank you, Mr. Samuel. Thank you, Unilag.
Thank you so much, sir. Thank you. And Mr. Ene, do you have anything to say?
Okay. For me, I want to encourage the participants to do not look at the field, because usually when people hear about quantum computing, they look at when once they start seeing the equation or some stuff, they get scared. Don't be scared. Just take the little you can. Just start gradually. Whatever question you ask, you have post on the Discord or post on the channel. We will help you out. You mustn't grab everything. Whatever you can do, just attempt it. You from there you'll learn. That's just my own advice. Don't be scared. That's just my own advice. Thank you very much. I wish you all a happy weekend. Bye.
Thank you, sir. Thank you, sir. And thank you, everybody. Thank you so much. I think we are going to be meeting, is it on 24 for the next program? Please let me confirm before we close. We are going to be meeting. Please, sorry. I need to check. Sorry, I'm not with my system. I have a battery low, so I'm unable to. Okay, for the next section, which we are going to be with the hands on the on section, we're talking of the first step with QISKIT and quantum socket foundational. Okay, Python is out. Implementation of algorithm and some other areas. So that's we are going to be meeting on 24th of this month, 24. Before that, I hope most of us will be done with um our notebook, which I will post this evening on the group on the platform for us to try. Just try it. Read the documentation. Many of us always go through novels, read it, try to understand it, and we will get it. So thank you so much. We are meeting on 24th of this month for the notebook, for the second notebook, which is the second class. So thank you, and God bless you all. Thank you so much. Have a wonderful weekend. Thank you. So we'll meet next class. Thank you. Thank you. Thank you. Thank you.